And hi. I haven't recorded in a really long time, and I know I probably said that like in the last 3 or 4 videos, but it's fucking true. I haven't recorded in a while, and well, I want to show like the manner generally because I don't know what I haven't shown. So yeah, I got this. This is really cool. Okay, move on. um, I also want to do a really talking video. I believe I won't do any cut in this video. So yeah, all I got the whole manor like filled with villagers. I believe I've already shown this, but I will do it anyway. But I got a lot more, I believe, since the last time. I got a lot more. I also got these crops down here. Is that no? And I got also these crops down here. Um, well, I don't know if I shown this, but I will anyway. I also got this, and I got a lot of wither skeleton skulls. This is where I trade like iron for emeralds. This is incomplete. This is complete. I really like this room. Ah, this is like a new painting. Yeah, it's I like it a lot. This is yeah, kind of complete. I mean, yeah. Well, it's acceptable. And I'm going to the second floor, and I believe there's something here I haven't shown, or have I? Maybe this? Nah, I've shown this already. Yeah, most likely. And yeah, in this floor, I doubt there's any new stuff. Maybe here, because I did this room that I just remember. I already shown. So yeah, I believe I've shown everything, everything in the manor. I haven't worked on it actually. Well, I've been really busy, like with college, so I haven't got like time to play. And I also want to play like other games. I'm gonna show you what I've been doing since the last time. I wanna play Bloodborne because I got like the chance to play it with an emulator on PC. I mean, it's kind of framey, yeah, and it lags a bit, and maybe there's sometimes like bugs and it crashes, but it's okay. And yeah, I did this like whole route with ice. It goes up to the farm, and this is like the main project that I've been focusing on uh, lately. I mean, lately, not as lately because I haven't played Minecraft like in maybe a month or more. But yeah, I'm mining the whole perimeter. I mean, it's not like the whole perimeter. It's like a slice up, like a inverted um, pyramid, because I like the idea. And there's a zombie. Ah, yeah, I'm playing in the 1.21.8, and I got like here's all the stuff I collected, and is actually isn't that isn't like a lot of stuff. It's actually from all of this, like the main resource I believe, like the most precious for me is the duff. I love duff, and I haven't really like worked on Duff with Duff in this world. So yeah, and look, look how fucking far the chests are with the stone. It just fell, completely fell to the top. Can I land on it? Yeah, like fell. It's amazing. So yeah, I've been doing this, and I also encountered two dungeons. This one had a golden enchanted golden apple. I have like right here. I won't look for it. And this one, the corner of it, but it has nothing actually. And yeah, also a lot of slimes. Like I haven't got the chance to make a slime chunk on like farm. So this is my slime farm actually for the time being. And this video I wanna mainly talk, not I won't do like much. Just wanna talk because I also youth path, and I don't know where my golden apple is. Well, somewhere around here, and I lost my thought. Maybe here? Nope. I got this geode. Kinda sick actually. I don't know if I'm ever gonna use it, but I mean, it's in there. So yeah, this episode I mainly wanna talk, and I wanna talk of something specifically. I don't have a like a script or something. I just wanna talk as it comes, and it's something I'm doing in college. Uh, so um, I'm taking part of a course in differential equations, basic differential equations like ordinary, and I got a project like was, uh, yeah, I got a task. Let's say it's not much a project but a task. I mean, in the beginning, because I like taken quite a fond of it, and it's predicting and making a model of the population growth in Alabama, since and we have a data from the 1800s to in the 2000s, like a 200-year data of the population in intervals of like 10 years. And yeah, the goal of that is looking for a model to predict how the population of Alabama will be, how the population of Alabama will, how do you say that? How we will grow in 2010 and 20 and 30, 40, 50. Like the sky and the limit in there is 2050. So yeah, I got like 200 years of data to predict 50 years. And yeah, the task says like I gotta I gotta use like two specific models which are like the best to model population growth, and those are the exponential, which is actually quite bad, and the logistic that follows a curve that eventually in time it will turn into a plane. Not a plane, a line, a straight line, horizontal straight line, constant, if you will. And this is much more like faithful to reality, because like populations like don't have like exponential growth infinitely, because if that was the case, we were like probably overgrown the earth. And you know, like wars happen, uh, epidemics happen, pandemics, you know, that stuff. Also technology like increases the population growth or decreases it. I don't know a case where technology like decreases the population growth. Yeah, that's an interesting concept now that I think of it. Um, but yeah, anyway, it mostly is like how the population in time it will grow, and which model of how do you manage the parameters of each model uh, to like adapt to the data you have. And I now just like today, like a couple hours ago, managed to make a quite good prediction of it. I mean, I'm really happy, and it's kind of weird because I just like dug into this really deep rabbit hole of information, of ways, of methods to solve the equations. Maybe like focusing on the logistic growth, and only to it for it to be like a, you know, really simple way of dealing with it, and with it having a really good estimations of the future. So much so that I like in one point just hit exactly the population of the time, like for like a margin of error like 5 or something, and it was quite good. Uh, but well, anyway, for some context, like population growth is basically a differential equation that is nonlinear and depends on multiple parameters. Those parameters are like the uh, growth rate, which is R or K in my model, how I call it, it's K. The initial population, like, no, you know, the function is P of t, the initial population is P sub 0 of t, P sub 0, not of t, and which is like the number when that you start with. And also you had like the equilibrium, like the solution of equilibrium, you know, where the functions eventually plateau. So you got a model like that is, if I believe d of p over dt it's equal to k times t, no, k times p, I open a parenthesis, 1 minus p over n, and you gotta solve that equation, and I mean, it's not hard, it's simple. It's non-linear, which is like quite bothersome, but you can do separation of variables, which is a method to solve differential equations, and you get a function of time of the population, and it's, if I believe and I remember, p of t it's equal to n over 1 minus a times e to the power of minus k times t, I believe that is, where a or c, as you like it, preferred, it's a constant of growth, and that constant, if you like plug the initial value p of t, no, p0 is equal to p equals 0. You got a equal to n minus p sub 0 over p sub 0, and you plug that into the equation, and yay, you got a population growth, which can be really good or really bad, depends on your data and what you try to do. In my case, was really bad because like the data, unfortunately, it didn't show a plateau actually, and the it was quite linear, like the whole time it was really linear, so you couldn't see like a clear indicator. It was a logistic model, so much so that I thought of doing a linear function. I mean, I did a linear function and it was really good estimation, and it will probably be a good estimation of the function, but I know it won't be linear forever, so eventually it will plateau. I don't know when it will plateau, but it will. Maybe in 200 years, 400, I don't know. Also, the plateau factor n or k isn't like in time units, it's in population. So it's not when it will plateau, it is how much, I don't know, maybe? I don't know like the correct term to refer to it. So anyway, that equation, it's quite tricky because you got a differential equation, well, as a function. Actually, now you got just a function, which is good, but that function, you got to how do you call that? What the fuck? I just lost my mind because I'm thinking that the chunk just lost range, so I gotta take it down. I'm gonna take it down and I will just continue. Well, I'm gonna talk while doing this because I don't got a lot of time. And well, what I was trying to say was that you got a single function with two unknowns, possibly three. I just realized, and that realization was the key to solve. I mean, not solve, but manage in a better way the problem. So the unknowns you have are three, as I just said, but in a way that one of them is like you can kind of see it by looking at the population, and it's n, the equilibrium, the plateau of the function, because as the population goes on, you see like a steady state, like it stays around like some value, so you kind of eyeball it, really just eyeballing it, and by that you just got a k or r, which is the growth factor, and the initial population, like the initial value. and that last one was the for me the key to solve it. I mean, not solve it, but you know. And but I was unaware of it because I thought that I could just leave a steady initial population, don't change it, and have it predict like the whole system, and it's obviously unrealistic. Is especially in my case where the initial population was one, I mean in thousands, so 1,000, and the final 220 or 200 years later, it's almost 5,000. So a logistic model clearly will lack the real values. So, and I'm gonna drop this. I'm sorry. Um. So yeah, I got K. Fucking hell! I just fuck. Um. I got K, right? Or R. How you find it? The voice to that to that, and I took like different routes. Just first of all, I eyeball it like the as the other ones. Wasn't very good. I mean, it's quite bad as you can imagine. Also try to do like I asked my teacher for help, and he said like take the I showed him a linear function that described really well like the data, and he said take the mean of the slopes, and that way you can have k. It was really like really little information, so I just went home and did it, and it wasn't like good actually, and it wasn't just that I like to really needed to take that mean, multiply it by 4 for some reason. I mean, I know the reason, but I won't take the time to explain. And then divide it by a value. I don't remember. Like n, you gotta divide it by n. And I did it, and it wasn't a good approximation actually. It was quite bad. Um, so I took other alternatives, like, and the last one I took, and I did it like looking for a paper where I was like really desperate actually, and basically what I did was, uh, I mean the paper was about a logistic model with a varying carrying capacity. So the carrying capacity was itself a logistic model. Um, so it was really interesting. I didn't end up using it, but maybe in the future. And what it said in the paper that really helped me was a way to find K, and the way was K it's equal to fuck. Let me see. K is equal to natural log of n, natural log of 81 over the difference of time in time that it takes for the function to reach from a 10% to a 90%. It's kind of random, but it works. it worked like really well, and I, the value of k that it gave me was 0 0.0183, and oh my god, I just realized something. Oh my fucking god, I just realized I leave that value of k after I switch n, so I gotta switch k also. Well, I'm gonna do it later. And fucking hell, I'm really losing myself. So with that, I find k, as I just said, and I plug it. Was kind of good, but it wasn't fitting that well. Like in the beginning and in the end, and never. It wasn't fitting actually. Just in the end, kind of was fitting, but not that much. So I wasn't happy still with it, and so I thought, well, I'm gonna vary the initial condition, so it maybe do something. And hell, it did something. It changed everything. It just changed everything, and it's amazing because after doing that, I said, well, I need to change a little the hold on, 84. Change a little some parameters, and I did like n. It went from 5,000 to 6,000, and it's a splendid. I mean, it worked like fucking magic. It's fucking amazing. And with the change that I'm gonna do later, like right now after I finish this, it will be even better, because with a initial point of like 18, like 40, let's say in the scale is 40, I could predict exactly the population in 220. Like that's a lot, like 180 years difference, and it can predict exactly the number, and it's amazing. And I just plotted everything in MATLAB and made it kind of fancy, and I'm really happy. I'm really happy. So yeah. I'm really happy because of that. For that, I'll do eventually like a video explaining it like in depth, and I don't know where. I won't. I doubt I will do it in this channel because it's completely unrelated, or maybe I will. I don't know. Like in a fancy way, because I really like the problem, and I do like other stuff. Like I also did like the Euler's method, like numerical methods, to estimate the function, and it wasn't, yeah, kind of good, similar to the logistic one. Well, because I use it as a base, the logistic one, and also I did the like Gillespie algorithm, which is quite nice actually. It takes like a function and it gives it an live or death factor, and basically it made it that there's noise in your function now, so it can like simulate like stuff happening, deaths and that thing, and like growth spores and deaths. So when I do that, like it determines that in a probability, x minus 1 and x plus 1, and it multiplies it by the well, not multiplies it, just if that probability hits, it will decrease or increase the population like in a nice way, like a big slope. So it gives the illusion of it, also in a random slope, so it gives the illusion of noise. So yeah, that's basically it. And I didn't end up like mining a lot, just building this. I forgot beacon. Yeah, I don't know when my next video will be because I just lost beacons. What the fuck? Oh, these ones. I'm so like completely centered in this shit. So yeah, I don't know if any videos are gonna come out in the near future. It's okay, yeah, it is okay. So well, see you sometime in the future, I guess. So yeah, bye.